All right, hello. Let's wrap this up. We are on lesson 3.4. So we are going to talk about systems of inequalities. This is our last lesson for this unit. And most of this is largely Algebra 1. A lot of this what you've already covered in Algebra 1, actually. But we're kind of tying it back again, doing a little gentle reminder in Algebra 2, and applying it to systems of equations as well. Okay, because I think in Algebra 1, you do single inequalities. I don't think you do systems, though. So we're just going to apply this to systems. Okay, so a quick reminder here. It may have been a minute since you've seen Algebra 1, right? So let's just remind ourselves. Y equals mx plus b. We all know what that is, right? Well, m is the slope, and b is the y-intercept. That's just a careful reminder right there. Maybe it's been a while since you've seen it, because I know we intersperse geometry here in between Algebra 1 and 2, but still, hopefully that's something you remember. Y-intercept, you should know that. Slope, slope is rise over run, or more formally, change in y divided by change in x. So it's how much are you changing vertically divided by how much are you changing horizontally. And also, you have there's a few ways we can write linear equations. Y equals mx plus b is known as slope-intercept form. This is slope-intercept. This is the easiest to graph because if you know the y-intercept and you have the slope, you just plot the y-intercept and then you use rise over run to get another point and then you draw a straight line. Reminder, to graph a linear equation, you only need 2 points. Okay, you just need 2. So long as you got 2 points, you can make a straight line through those points, you are good. All right, you're good. So that's that. But at the same time, not all of our equations are going to be in slope-intercept form. So they're not always going to look like y equals mx plus b. Reminder that sometimes we write these things in standard form, which is ax plus by equals c. So if you get something in standard form, there's a few ways you can go about graphing these lines. Again, this is just really Algebra 1 review. One thing you could do is you could find the x and y intercepts by plugging in 0 for y and then 0 for x. If you don't know how to do that, just come talk to me. I don't want to really cover that in this video, but that's something you could do. Or you could change standard form, this is called standard form, into y equals mx plus b. And to do that, you would just solve for y. So you'd subtract ax and divide by b. And then that would be slope-intercept form. And hey, who knows? Maybe there'll be one in point slope form, right? Who knows? Okay. But let's start graphing these things. So the first thing you want to do is graph the line itself. But before we do that, another reminder. Take a look at my system here. I've got greater than, and I've got less than or equal to, right? This distinction matters because less than and greater than, if you graph these inequalities, if you graph a line, you need to use a dotted line to indicate the line because for it to be strictly less or strictly greater than means it doesn't actually touch the line. It's not actually on the line. It's either above or below it. And then if it's equal to, well, then that's when you can make a solid line. All right? So keep that distinction in your head. Maybe jot that down in your notes. Careful with that, okay? Because you need using solid lines and you need dotted lines, depending on what inequality symbol you see. Okay, I'm going to gently erase these. Bloop, 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 bloop. Okay. And maybe the last thing I'll say as a reminder, when we work with a system of inequalities, the idea of a system is that your solution set must satisfy every equation in the system, or in this case, every inequality in the system. So whatever my region is, it needs to satisfy both of those, not just one, both. because it needs to be a solution set to everything in the system, okay? Which means we're going to be shading, okay? We're going to be doing shading of sorts. When I shade, you want to look for the overlapping regions. That will be our solution set. And you'll see what that looks like in just a second. Is there anything else I wanted to add on that? I don't think so. I guess we'll just move as we go along, yeah? Okay. So first of all, let's just plot this, right? So I've got this equation right here. Y is greater than 2/3 x minus 4. So to plot this, the y-intercept is -4. So I'm going to go down 1, 2, 3, 4 right here. There is my y-intercept at 0, -4. And the slope is 2/3. So rise over run, right? 2/3 rise over run means I'm going to go up 2. So I'm going to say 1, 2 over 3. Oops. It held it too long. Sorry. 1, 2, and then over 3. 1, 2, 3. And that's where I'm going to put my point right there. But I don't really want those, so I'm going to put that. And I can put down some more points. Now, I did say you only need 2. Okay, you only need 2. But Mr. Spake likes to be efficient. I'd like to have a really nice, accurate graph. So I'm actually going to put a few more here. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. And then maybe I'll go backwards. Down 1, 2, 1, 2, 3. Maybe down 1, 2, 1, 2, 3. Okay? This is just for my sake. Now, through these points, we talked about less than, greater than means a dashed line. So that's what I need to do because there is a strictly greater than sign. So that's what I'm going to do. I'm going to make a greater than sign is dashed line. So here we go. I'm going to say boop, boop. I'm trying to do this as straight as possible. On your paper, you need to be using some sort of straight edge when graphing these, okay? They better look pretty darn nice. Now we're in the point of the semester where Mr. Spake's going to get a little bit more picky with our graphs, okay? You got away with it in Unit 1 because you were, just being introduced to them. But now this is where I'm going to really be looking for, does that look like a straight line, yeah? So there it is. There's my dotted line. But I want to shade this inequality. So I'm going to switch colors here. I'm going to say, let's use red. We'll use red for that equation right there, or that inequality right there. For y to be greater than something, well, y is a vertical thing, right? Up and down. So if it's more than something, vertically, that means it's above, right? More means above. So it's taller, right? It's above. So I'm going to take my little pen here and just very lightly, on a paper, I would just sketch this lightly. On here, I'm going to just kind of, here we go. See how I'm going up from the line? So I'm just sort of shading up above this line, okay? Now let's graph the other line, because we're not done. That's only half of it, okay? So now my next one is y is less than or equal to -3x. There is no b value present, so that means it's 0. So the y-intercept is at the origin, 0, 0. And a slope of -3 means down 3 over 1. So it means go down 1, 2, 3 over 1. Down 1, 2, 3 over 1. 1, 2, 3 over 1. I'm going to put some more points. 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. Okay? You don't need to put this many points. I like to. Okay, that's a me thing. You just need exactly 2 points. That's enough. That will suffice. And put a straight line right through all of them. Look at that. I'm going to say boop, boop. Okay? So that's that line. But I'm doing the inequality, so let's use blue here. So say blue. And we want to shade, y is less than, or equal to. Notice I used a solid line because it was equal to. Y is less than means shade below. So shade below, because you are down, you are beneath the line, less than the line. So I'm going to, I usually draw one of the regions vertically and then the other one's horizontally. In this case, I have different colors, so it doesn't really matter. But everything beneath that line. Can you see it? Yeah? Yeah, you can see it. So what I'm looking for is the overlapping region, right? The overlapping region is my solution set. So I'll get my highlighter. It needs to be above this and below that. So really what I'm just looking for is the region where it's red and blue together. And that region is here. I'm going to make this, yeah, I'm just going to nice little shading here. Look at that. Isn't that so nice? I'll even shade a little bit more. Look at how much I can fill in. Look at that. Oh my gosh. Isn't that beautiful? Okay. So that highlighted region is my solution. Okay. And that's it. That's pretty much it. The highlighted region is my solution. Okay. So let's move on. Let's do another. And by the way, what this means is any point in this region, any point is part of the solution. So if you had a question that says, hey, is this point part of the solution? You'd say, yeah, it is, because it falls in that region. Notice points out here or out here are not part of the solution set, even though they satisfy one of the inequalities. All right. Example 2, and I really only point this just as a reminder, okay? Just as a reminder that if it's not in slope-intercept form, you want to probably get it in slope-intercept form, unless you can solve it using x and y intercepts, in which case, hey, fair game, go ahead, you do that, okay? But I'm going to do y equals mx plus b, because that's what I'm used to. That's just me. So let's say I've got 3x plus 5y is less than or equal to 10. This is an equation in standard form. I want to get this in slope-intercept form, so I will subtract 3x from both sides, and I get 5y is less than or equal to 10 minus 3x, and then I'll divide both sides by 5. So this is y is less than or equal to, what is that, 5 minus 3/5 x. Okay? Which means the y-intercept is 5, so 1, 2, 3, 4, 5 is my y-intercept. The slope is negative 3/5, so it's down 3, 1, 2, 3, over 5, 1, 2, 3, 4, 5. Okay? And this one is equal to, so I go up 1, 2, 3, 1, 2, 3, 4, 5. Okay, I like it. Look at that. Isn't that nice? Isn't that lovely? I think that's just grand. Look at that beautiful line. Oh, I can't get enough of it. All right, so that's that one. And we could shade that, right? We'll use red again. Red. Notice it is less than or equal to, but probably what you should be looking at is this. That's the other thing. That's probably the other thing I should say. Maybe don't plot it with the y and x intercepts using standard form, just because you need to analyze the inequality on y. You would get away with it here and be fine, but that second one is actually going to screw you up if you don't put it in slope-intercept form. So be careful there. Less than means below, so I would shade beneath this line. I mean everything beneath, everything. Okay? Next line, I've got x minus y is greater than 6. So So bring this down. X minus y is greater than 6. I'm going to subtract x from both sides, so I get negative y is greater than 6 minus x. And then I'm going to divide by a negative 1, so that positive y is less than negative 6 plus x. Notice what I kind of did there, right? I divided by a negative, so all the signs flipped, and because it's an inequality, division by negative flips the inequality sign as well. So now that I've got that, let's do it in blue. I say, whoop, this fella, and this is in blue. Oh, but I have to plot it first, don't I? Sorry. Let's plot it. Slope is 1, and the y-intercept is negative 6. So it's going to be 1, 2, 3, 4, 5, 6 down right here. And the slope is 1, which means it's just kind of going to up 1 over 1, right? Up 1 over 1. So forth, like that. By the way, you don't have to put all those points, but I like to. And because it is not equal to, that means it is a dotted line. Like so. Hooray. And now take a look. It says y is less than, right? Y is less than, which means it's below the line. So below the dotted line is everything here. Right? That's everything beneath. So really what I want is the region beneath both lines. So I'm going to take my highlighter. You don't have to highlight this on your paper with a highlighter. You could just shade this. Just do light sketches for the red and the blue if you don't want to color code. And then just with your pencil, darkly shade your solution set. That's what I'm going to do here. Okay? Because it is beneath both lines. Okay? And there it is. Wow! Look how beautiful this is. Isn't this fun? I like this. So we're plotting lines and we're shading. That's all we're doing. Okay. I want to do one more. You've probably got it by now. But hey, more examples, the merrier, right? I'm going to do one last one. And I only want to do this one because of, you see how I have y and x with no, these are going to be straight horizontal or vertical lines. So first one I've got here is y is less than or equal to 2x. So to plot that, there's no y-intercept, so it's at the origin. I shouldn't say there's no y-intercept. That's bad language. Improper, I say. The y-intercept is at 0 because we don't see a b, so it implies b is 0. Okay, and then the slope is 2, so up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And I'll do the same backwards, like so. And this is going to be a solid line since it's equal to. So draw through our lines like so, making it straight, okay? And it is below. So I'm going to say here's blue. Y is less than means it's below this line. So it's everything beneath that line. All right? Now let's look at the line y is greater than or equal to negative 2. So what you want to graph is the line y equals negative 2. That's what you want to graph. And y equals negative 2 is a horizontal line at negative 2. So I'm going to go down 1, 2. If you can see my pen, the marks I just did there. And I'm going to put a horizontal line. This is a solid line, by the way. Horizontal line here at y equals negative 2. And this is greater than, so red, greater than meaning above. So I'm going to take my pen and go everywhere above that line. Okay, so far I can kind of see where the overlapping region is. But I got to do one more, and that is at x is greater than or equal to negative 1. Okay, so that means x equals negative 1, which is a vertical line at x equals negative 1. So that's over here, like so. This is getting a little hard to read. You know what? Let me erase these since there's just so many. Gosh darn, there's just so many. I think I could draw this better, so it's not too crowded. No. Okay, so that it's not too crowded. I don't know. I feel like if I do, it's gonna get just too darn crowded. So we'll just use it as visual reference. So you know that I'm shading above this line. You know that I'm shading below this line. And now, since x is greater than or equal to negative 1, well, x is greater means go to the right, right? Because, so if this is negative 1, more than negative 1 horizontally is to the right. So you would have, if I used green, you would have lines extending like this, right? But they have to satisfy all three. So the shaded region here, it's beneath this line. It's above the line on the ground right there, and it's to the right of x is greater than or equal to negative 1. So really it's just everything here. Everything here. And that's my shaded region. Okay? Isn't that nice? I think that's pretty nice. Okay. Yeah. So there you go. That's my shaded region. All nice and pretty. Maybe I'll put like just a couple lines like this. And then red was like this. And then blue was like this. So that's where the overlap is. I don't know. Is that too confusing? I don't know. I don't know. I kind of think it is. I don't think I want to include that in the notes. Okay, at this point, I think I'm just yammering on. So that's pretty much it for the lesson 3.4. There are some word problems on the homework. I might make another video sometime talking about word problems, but for the most part, you're just setting them up. All right, you're just setting them up on your own. So there you go. Okay. Well, hope this was helpful. And this wraps up Unit 3. So there you go.